So we are going to start the topic, that is superposition of wave. So first of all, anyone having any idea what is meant by superposition of wave? Suppose we are sitting in a class or in a room. Many persons are sitting in a room, and everyone is continuously talking. Okay, that means everyone is producing a sound wave in a room. Okay, so what will happen? Will you be able to understand everything very clearly? सब लोग जैसे एक क्लासरूम में जब सारे बच्चे एक साथ बात करने लगते, तो हमको बात उनकी समझ में आती है सबकी बात क्या बोल रहा है? नहीं ना, क्योंकि उस टाइम पे ऐसा होता है, many sound waves are produced at a single time, so every particle in that system is performing multiple simple harmonic motions. Okay, जैसे एक वेव के लिए एक पार्टिकल एक सिंपल हार्मोनिक मोशन परफॉर्म करता है, लेकिन जब एक ही पार्टिकल को बहुत सारे वेव्स के थ्रू जाना पड़ रहा है, so it has to perform many simple harmonic motions at a single time. So that type of interaction between the waves is called superposition of wave. Okay, suppose here we have the definition of superposition of wave, and it says that when two or more waves traveling through a medium pass through a common point, each wave produces its own displacement at that point, independent of the presence of the other wave. The resultant displacement at that point is equal to the vector sum of displacement due to the individual waves at that point. Okay, so basically what they are trying to say, suppose in a room two sound waves are produced simultaneously. Okay, let me show this by an example. Here, let me show you. Let me go to that page. So here we have the term wave interference or superposition. Okay. Now see here. Suppose we have two wave pulses. Okay. When a wave have only single either crest or trough, that is called wave pulse. Wave pulse meaning सिर्फ उसमें या तो एक crest रहेगा या फिर एक trough रहेगा. So here in this diagram, one wave pulse is moving towards the right and the other one is moving towards left. So what will happen with these waves when they come or they superimpose on each other? Okay, so let's see what happens over here. See, let me run this. Okay, so here you see, let me slow it down. Here you will see two waves are approaching to each other. One wave from this side and the other one is from left side. The other one is from right side, approaching each other. So when they come very close to each other, here you will see this is the displacement for particle 1 and wave 1, and this is the displacement for particle 2. So what will happen to the particle over here? यहाँ पे जो पार्टिकल होगा इस पोजीशन पे उसका डिस्प्लेसमेंट क्या होगा, that we want to find. So the displacement of this particle will be finalized by adding the displacement of first wave plus adding the displacement of second wave. So if I run this again, here you will see the displacement of the particle over here is continuously increasing, and at the end you will find here this point is the actual displacement of the particle due to these two waves, the orange one and the green one. Due to these two waves, the displacement of the particle is over here. तो बेसिकली कैसा होगा, एक वेव इधर से जा रहा है, सपोज दिस वन, एंड द अदर वन इज हियर. So what happens over the to the particle over here, the displacement of these two waves gets added to each other. Okay, is it understood? समझा? Or should I explain it again? Let me run this again for you, so you will have a better understanding. Here, see it clearly. They are moving away from each other. Now they will start approaching towards each other. See, they both are approaching towards each other, and when they overlap each other, now they will start overlapping each other. Here they have overlapped each other. This is wave 1, this is wave 2. Okay, so यहाँ पे जो पार्टिकल्स होंगे इन दोनों वेव्स की वजह से, उनका डिस्प्लेसमेंट हमें फाइंड आउट करना है कि उनका डिस्प्लेसमेंट क्या होगा. तो बेसिकली दैट डिस्प्लेसमेंट ऑफ दैट पार्टिकल will be the addition of displacement due to this wave and displacement due to this wave. तो दोनों के डिस्प्लेसमेंट को जब हम ऐड कर देंगे तो फाइनल डिस्प्लेसमेंट जो पार्टिकल का है वो यहाँ पे होगा. ओके, तो ध्यान से देखना, इसमें कैसा था, दोनों ही क्रेस्ट थे. इफ यू सी बोथ दी वेव पल्सेस आर क्रेस्ट, कोई भी इसमें ट्रफ नहीं है. करेक्ट, बोथ आर क्रेस्ट. तो जब दोनों के दोनों क्रेस्ट होंगे तो उनका डिस्प्लेसमेंट कैसा होता है, ऐड हो जाता है. नाउ इफ वन वेव पल्स इज क्रेस्ट, अगर सपोज ये वाला क्रेस्ट है, द अदर वन इज ट्रफ, तो क्या होगा वो हम लोग देखते हैं. वो मैं बोर्ड पे एक्सप्लेन करता हूँ. So suppose one wave pulse is crest and it is approaching towards a trough like this. Okay, so this one is crest and this one is trough. So when they overlap each other, जब वो एक दूसरे के वो overlap करेंगे like this one will come here and this will go down like this. Okay, so what would happen to the particle over here? यहाँ पे जो particle होगा उसका displacement क्या होगा, because we want to find the displacement for that particle. यहाँ पे जो particle है वो उसके पास दो displacement है, one displacement is up, the other one is down. So basically they both displacement cancel each other और पार्टिकल कहीं नहीं जाएगा इस बार. ऐसे टाइम पे पार्टिकल कहाँ पे रहता है, अपने मेन पोजीशन पे. ओके, सो वी हैव सीन टू केसेस व्हेन टू क्रेस्ट अप्रोच ईच अदर. अगर दो क्रेस्ट एक दूसरे को ओवरलैप करते हैं तो डिस्प्लेसमेंट ऐड हो जाता है और उसका डिस्प्लेसमेंट कैसा मिलता है, मैक्सिमम. बट व्हेन वन क्रेस्ट and one trough is approaching each other, the displacement is zero. A displacement of the particle which is performing simple harmonic motion is zero. Is it understood?
Yeah, sir.
Okay. Let's see some other examples. There is so suppose we have two waves, okay, like this. One is red, the other one is green. when they superimpose on each other, मतलब ये अगर एक दूसरे के ऊपर से पास होंगे तो जो एडिशन होगा वो ये जो बना है हिंदी उस पर पर्पल है. Okay, so this is the addition of these two. Now if you see them, दोनों waves कैसा है, same position से start हो रहा है. The red one also the green, both are starting at the same position because we have kept them in a same phase. If you see here, it is in same phase. Same phase means they are going to start from same position. But when I put them in out of phase, अगर मैं इसको आउट ऑफ फेज कर दूं, अभी देखना, see, one is starting, one is going in the upward direction, the other one is going in the downward direction. That means they are out of phase by 180 degree. इन दोनों के बीच में जो फेज डिफरेंस है वो कितना है, 180 डिग्री. ओके, सो तो इनका जो रिजल्टेंट बन रहा है वो जितना क्या है, कुछ भी नहीं है. The displacement of the particle is zero. It is a straight line. Here you will see a straight line. You can see here over here a straight line. Why? Because this one is crest and this one is trough. तो जब एक crest एक trough को overlap करेगा, the particle will be at the mean position over here. So we get a straight line. Okay, is it clear?
Yes, sir.
Again, suppose I change the phase difference by 90 degree and I keep it over here 90 degree. Okay. So as you can see, when I change the phase difference, I can put it 0, I can put it 180 degree, I can put it 360 degree, any case. तो जैसे ही हम लोग इन दोनों के बीच में फेज डिफरेंस चेंज करेंगे, द डिस्प्लेसमेंट, वो जो रिजल्टेंट डिस्प्लेसमेंट होगा इसका, दैट आल्सो चेंजेस. Okay, so when these two waves are getting added, the resultant of this is here. Let me play it. If I change the phase difference, I keep in the same phase. अगर दोनों को same phase में रख दिया, like this, they are in same phase, the resultant displacement of the particle is maximum. Now when I try to keep them out of the, जैसे जैसे मैं इसका phase difference change करूंगा, the resultant wave is also getting decreased. वो धीरे धीरे decrease हो रहा है, and at the end it becomes a straight line. That means there is no result. और ऐसा कब होता है, when one crest is facing one trough. Is it clear? So here we have written in phase. In phase means when both the waves are starting from same position. When both the waves are starting from same position, we say that they are in same phase. But what is meant by out of phase? Out of phase means both are moving in the opposite direction. If one is going in the positive direction, the other one is going in the negative direction. Okay, so when both waves are in phase, we call constructive interference. This is not the topic from this chapter. You will study in the interference chapter. तो ये भी नहीं बताता. Now we are going to find the equation for the superposition of two waves. अभी जैसे ये दो वेव superimpose होके ये resultant displacement होता है, ठीक है. तो अभी हम लोग इसी के बारे में उसका mathematical expression लिखने वाले हैं. Okay, so anyone having any doubt till now, they can ask. Then we can go to the mathematical expression. For that I have to use board. Yes. Okay. So now I'm going to start from the mathematical expression. Okay. So we are going to find the amplitude of the resultant wave. So our next topic is amplitude of resultant wave. Suppose I consider two waves. Okay. So let's consider two waves of same frequency but different amplitude. But different amplitude. A1 and A2. Okay. So basically, I have to consider two waves. Okay. One wave is having amplitude A1. The other one wave is having amplitude A2. We all know that basically a wave is represented by, हमने mathematical expression last lecture में देखा था, that it is given by a sin kx plus omega. Correct? Any method wave is represented by this mathematical equation. But here I will consider the displacement, that is the value of x at 0. So we can consider, let the value of x equal to 0 and phase difference d phi. हमने क्या कंसीडर किया? The displacement, that is the value of x is 0 and the phase difference between these two waves is phi. So first, what would be the equation for first wave? पहला wave जो होगा उसका equation, let it be y1. Okay. So the equation would be a sin. Here for x I have substituted 0. That means it would be like sin omega 2. This would be the first equation. Similarly, for second equation, amplitude I have to take A1. Here also A2 sin omega t plus, see here, I have taken that the phase difference between these two is phi. So अगर इसका phase 0 है, then for this the phase would be phi. Okay. So one wave is A1 sin omega t, the other one is A2 sin omega t plus phi. Here in this topic we have to find the resultant amplitude. Okay. So to find the resultant amplitude we have to add these two. इन दोनों का सुपरइम्पोज होगा, मतलब एक दूसरे को ओवरलैप करेंगे. So we can write by principle of superposition. Superposition. We have to add these two by principle of superposition. So y would be equal to y1 plus y2. Okay. Now substitute this equation over there. So you will get phi equal to a1 sin omega t plus a2 sin, come करो, take this screenshot for this, then I will write here only. इसके लिए स्पेस ज्यादा लगेगा, तो first take this screenshot. Yes, is it done? Why no one is speaking today? Are you able to hear me?
Yes,
or
sir.
everyone is busy somewhere else? So we have to find the resultant of these two. Let me write it over here again. Y equal to y1 plus y2. Yes, are you able to hear me?
Yes, sir.
Okay.
sir.
Why no one is responding when I am asking the question? Okay. So we have to add these two equations. First equation was y equal to a1 sin omega t plus a2 sin omega t plus phi. Okay. Now in this equation I can use the formula sin a plus b. Okay. So if I, by using that formula, if I expand this, then we can write the equation as a1 sin omega t plus a2 sin omega t into cos phi plus a2 cos omega t into sin phi. So in these two equations, sin omega t is common. As you can see, sin omega t is common, so I can take it out. So we will have a1 plus a2 into cos phi and bracket के बाहर sin omega t and plus a2 cos omega t into sin phi. Okay. Now, if you see in the bracket here, this phi phase difference is constant. Okay. So I can consider this whole bracket as, let a1 plus a2 cos phi equal to a sin theta. Okay. I have just considered this whole bracket as a cos theta. A cos theta, and this bracket just and a2 sin phi as a sin theta. These two equations are very important. Equation number 1, this is equation number 2. Okay. So For this, I will substitute a cos theta, and for a2 sin phi, I can substitute a sin theta in this equation. So our equation will be y equal to, instead of writing this, I can write a cos theta multiplied by sin omega t plus a sin theta into cos omega t. यहाँ तक समझा? Is it understood?
Yes, sir.
Take it down till here. यहाँ तक लिखो, उसके बाद नेक्स्ट स्टेप देते हैं इसमें क्या होगा. Do it fast. Okay. So next, here if you see in this equation, it is in the form of cos A sin B sin A cos B. So in short form, I can write this as y equal to A sin A plus B, and what is A? It is omega t plus theta. Okay, so this is the resultant equation for those two waves. Okay, so this is the final resultant expression. This is equation of resultant wave. But in this equation, we have to find the resultant amplitude. What would be the resultant amplitude? So for finding the resultant amplitude, we have to use these two equations. Okay. How we can use this equation? We have to just add these two equations by squaring. Okay. So we can write squaring and adding equations 1 and 2. We have to just take the square of these two equations and then add, then we can find the resultant amplitude. Okay, so let's take this square. सबसे पहले इसका स्क्वायर लेंगे, तो स्क्वायर होगा a1 plus a2 cos phi the whole square equal to a1 cos theta the whole square. Here also we have to add now. We have to add these two equations. इसका विस्तार लेंगे तो आएगा a2 sin phi the whole square. Okay. Now this time, so a square cos square theta plus a square sin square theta. Now for this bracket, you have to use the formula a plus b the whole square. So this will become a1 square plus a2 square cos square phi plus 2 a1 a2 cos phi. Okay. And plus this, that is a2 square sine square phi. Here you will see a square is common. Sine square plus cos square will become 1. So in this side you will get a square. We have to find the amplitude. Here we have the a square. Now we want to find just a. So I have to take this square. In this equation also, this side, here we have a2 square cos square, and here we have a2 square sin square. So sin square plus cos square becomes 1. So finally we can write the equation as a square equal to a1 square plus a2 square plus 2a1 into a2 cos square. So just take this square root. A square root would be a1 square plus a2 square plus 2a1 into a2 cos square. So this is the resultant amplitude of those two groups. Resultant amplitude. Okay. Is it understood?